Assalamu alaikum students. We continue unit number 3 with the law of change of bases. As you people know that in the introduction of a logarithm we learned that we have common logarithm and natural logarithm. So this law will help us to convert the values of common logarithm to natural logarithm and natural logarithm to common logarithm. And we learn this with the help of example of different bases. But before this, we prove that law. This law has two parts. In first part, we have to prove log n to the base a is equal to log n to the base b multiply log b to the base a. And in the second part, we have to prove log n to the base a is equal to log n to the base b divided by log a to the base b. Let's prove this law. To prove this, we take this value equal to variable x. Let log n to the base b is equal to x. We name it as equation number 1. As this equation is in logarithmic form, we have to write in exponential form to proceed. We have b raised to power x is equal to n. As we know that base remains base, equal value will become power and n will become equal value. We observe that in right hand side we have n and in that requirement we have log n to the base a. If we take log base a of this side, we have the one part of the requirement. So taking log to the base a of the both sides, we have log b raised to power x to the base a is equal to log n to the base a. As we know that this is the form of the log which is in exponent, so therefore we apply the law of exponent, meaning the third law of log on this left hand side. Power will become coefficient x of the log b to the base a is equal to log n to the base a. In this equation x is unknown and we know that the value of x we let that is equal to log n to the base b. So by putting that value in this equation, the value of x in this equation, we have log n to the base b, the value of x, multiply log b to the base a is equal to log n to the base a. Applying the symmetric property, we exchange the sides, left side to the right and right side to the left. We have and hence we prove its first part, according to which the log n to the base a is equal to log n to the base b multiply log b to the base a. In this we observe that in the first value we have log n and we take the arbitrary base, the base which we choose by ourselves, that is b. The same base which we take, that is written as the value of the log b, and we write base a from the base of the left hand side, the same base which is used in the left hand side. So that is the law which we prove, and in this we observe that the change of the bases. Now we move to the proof of the second part, and that is log n to the base b over log a to the base b is equal to log n to the base a. As we observe, n is present in these two values, so if we take n is equal to a, what happens? We replace that a over here, and we know that if log of the number and its base is same, they will be equal to 1. Taking n is equal to a and put in the above equation, we have log a to the base a is equal to log a to the base b multiply log b to the base a. As we know that log a to the base a is equal to 1, that is, if log of a number and its base is same, then they always be equal to 1. So we put that value in this equation. We have 1 is equal to log a to the base b multiply log b to the base a. Now according to cross multiplication, we take this value to the left hand side. We have 1 over log a to the base b is equal to log b to the base a. We get the value of log b to the base a, which when substituted in this equation, we get the required results. For this, we name it this equation as equation number 2. Log n to the base a is equal to log n to the base b multiply, we put the value in place of that log b to the base a, we have this 1 over log a to the base b. Multiplying log n to the base b to the 1, we have log n to the base a is equal to log n to the base b whole divided by log a to the base b. Hence, it is proved. Now we learn how this law will help us in the change of bases problem. As we know that in log n to the base a is equal to log n to the base b divided by log a to the base b, we observe that the log n remains the value of log in numerator. So log n to the base b is arbitrary base, the base which we choose by ourselves as common base, and in the denominator the base will be the same log b, and the base in the left hand side log base a, that will become the value of the log a. So that is the fourth law of log which we apply on each section in which we have different bases, base 2 and in this base 3. And if we have to deal such a problem in which the values of the log are required, log 3 is required, log 8 is required, and their product as well, but their bases are different. For such a difficult situation, the fourth law will make it easy, and we apply it and get log 3 will become numerator and log 2 multiply log 8 in the numerator, and the base will help us to write log 3 in the denominator. So the question may arise in your mind that, sir, where is the base? As we know that in common logarithm the base is 10, and we know that it is understood that by convention we do not write base 10 in common logarithm. Now we have these values in common logarithm and we can easily simplify these. Log 3 is cancelled by log 3 and we have log 8 divided by log 2. 8 is a composite number, and we can find its prime factors as 2 4s are 8, 2 2s are 4 and 2 1s are. So 2 3 times is equal to 8. So we have log 2 into 2 into 2 divided by log 2. So in a product, if bases are same and the powers are added, so we can write as log 2 raised to power 3 whole divided by log 2. Applying third law of log, that is law of exponent, as we have an exponential value 2 raised to power 3 with log So apply third law of log. On numerator we have 3 log 2 divided by log 2. We observe log 2 is the same in numerator and denominator. They are cancelled and we have 3. So hence we find the value of the product of the log having different bases by a simple application of the fourth law, and that is log 3 to the base 2 multiply log 8 to the base 3 is equal to 3. So hence we find a simple method of calculation of the values of log having different bases. So I hope you learn why we use logarithm